masala. First chapter, effects of electric current. Let us assess. First question is that fuse wire is to be understanding the amperage correctly. Write down the amperage of the fuse wires that are currently available in the market. They are 1 ampere, 2 ampere, 2.2 ampere, 5 ampere and 15 ampere. Second question, 0.5 ampere current flows through an electric heating device connected to 230 volt supply. This question has 4 sub-questions, so let's discuss A. The quantity of charge that flows through the circuit in 5 minutes is. They are given 4 options: 5 coulomb, 15 coulomb, 150 coulomb and 1500 coulomb. Here I equal to 0.5 ampere, T equal to 5 minutes. We know that I equal to Q by T. Therefore, Q equal to IT. Here, Q equal to 0.5 into 5 into 60 because 1 minute is equal to 60 seconds. Therefore, it is equal to 0.5 into 300. So, the answer is 150 coulomb. B. How much is the resistance of the circuit? Here, V equal to 230 volt, I equal to 0.5 ampere and we know that R equal to V by I, which is equal to 230 divided by 0.5. So the answer will be 460 ohm. Note that ohm is the unit of resistance. C. Calculate the quantity of heat generated when current flows in the circuit for 5 minutes. Here, I equal to 0.5 ampere, V equal to 230 volt, T equal to 5 minute. We know that H equal to VIT, so it will become 230 into 0.5 into 5 into 60, which is equal to 34,500 Joule. Joule is the unit of energy. D. How is the power of the heating device connected to the circuit if we ignore the resistance of the circuit wire? Here I equal to 0.5 ampere, V equal to 230 volt. We know that P equal to IV, which is equal to 0.5 into 230. So the answer will be 115 watt. Note that watt is the unit of power. Now let's move to the third question. Third question is, according to Joule's law, the heat generated due to the flow of current is H is equal to I square RT. Will the heat developed increase on increasing the resistance without changing the voltage? Explain. Heat developed will not increase because at constant voltage heat decreases on increasing the resistance. Fourth question. The table shows details of an electric heating device designed to work in 230 volt. Complete the table by calculating the change in the heat and power on changing the voltage and resistance of the device. Analyze the table and answer the following questions. We have 3 questions to answer based on the table. So the first question A. How does the voltage under which a device works affects its function? The answer is, when voltage increases, power increases. B. What change happens to power on increasing the resistance without changing the voltage? The answer is, power decreases. C. What change is to be brought about in the construction of household heating devices in order to increase their power? We have to decrease the resistance. Fifth question A. Complete the table based on the amperage of the fuse wire. B. The amperage of the fuse wire used in a circuit that works on 230 volt is 2.2 ampere. If so, the power of the device is. Options are less than 300 watt, 300 watt to 500 watt, between 500 watt and 510 watt, or more than 510 watt. So let's check the answer. Here V equal to 230 volt, I equal to 2.2 ampere, and we know that P equal to VI. So it becomes 230 into 2.2, which is equal to 506 watt. So the answer will be between 500 watt and 510 watt. Sixth question. A 230 volt 115 watt filament lamp works in a circuit for 10 minutes. A. What is the current flowing through the bulb? Here P equal to 115 watt, V equal to 230 volt. We know that P equal to VI. Therefore, I equal to P by V, which is equal to 115 by 230. Therefore, the answer is 0.5 ampere. B. How much is the quantity of charge that flows through the bulb in 10 minutes? Here, I equal to 0.5 A, T equal to 10 minutes. That is 10 into 60 seconds. We know that I equal to Q by T. That is Q equal to IT, which is equal to 0.5 into 10 into 60. So the answer will be 300 coulomb. Coulomb is the unit of charge. Seventh question. An electric heater conducts 4 ampere current when 60 volt is applied across its terminals. What will be the current if the potential difference is 120 volt? Here I equal to 4 ampere, and let the first potential difference be V1, which is equal to 60 volt, and the second potential difference V2 equal to 120 volt. We know that R equal to V1 by I, that is 60 divided by 4, which is equal to 15 ohm. Now we have to find the new current I. That is, when 120 potential difference is applied, the current I equal to V2 by R, which is equal to 120 divided by 15. So the answer will be 8 ampere. Eighth question. 3 resistors of 2 ohm, 3 ohm and 6 ohm are given in the class. A. What is the highest resistance that you can get using all of them? To get the highest resistance, we can connect the resistors in series. So the effective resistance will be R1 plus R2 plus R3, which is equal to 2 plus 3 plus 6. So the answer is 11 ohm. B. What is the least resistance that you can get using all of them? In order to get the least resistance, we must connect the resistors in parallel. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by 2 plus 1 by 3 plus 1 by 6, which is equal to 3 plus 2 plus 1 whole divided by 6. That is equal to 6 by 6. So the answer is 1 ohm. C. Can you make a resistance 4.5 ohm using these three? Draw the circuit. Yes, we can make. The circuit is given here. Ninth question. A girl has many resistors of 2 ohm each. She needs a circuit of 9 ohm resistance. For this, draw a circuit with the minimum number of resistors. We can draw the circuit as shown in the picture. Here, 4 resistors are connected in series and 2 resistors are connected in parallel. The effective resistance of resistors connected in series is equal to R1 plus R2 plus R3 plus R4, which is equal to 2 plus 2 plus 2 plus 2, that is equal to 8. R5 and R6 are connected in parallel. Therefore, 1 by Rp is equal to 1 by R5 plus 1 by R6, which is equal to 1 by 2 plus 1 by 2, that is 1. Therefore, the resistance of the resistors connected in parallel is equal to 1 ohm. So, the effective resistance R equal to Rs plus Rp, which is equal to 8 ohm plus 1 ohm is equal to 9 ohm. So, we get a circuit of 9 ohm resistance. 10th question. If a bulb is lit after rejoining the parts of a broken filament, what change will occur in the intensity of the light from the lamp? What will be the change in the power of the bulb? When the filament is broken, the length decreases, effective resistance decreases, current increases. Hence, power, light, heat, etc. increase. 11th question. Which of the following does not indicate the power of a circuit? A. I square R, B. VI, C. IR square, D. V square by R. The right answer is IR square. Let V1 equal to 220 volt, P1 equal to 100 watt, V2 equal to 110 volt. We know that P equal to V square by R. So R equal to V1 square divided by P1. Here R equal to 220 square divided by 100, that is equal to 484 ohm. P2 equal to V2 square divided by R, that is equal to 110 whole square divided by 484. So the answer is 25 watt. 13th question. Which of the following should be connected in parallel to a device in a circuit? Options: A voltmeter, B ammeter, and C galvanometer. The answer is voltmeter. 14th question. When a 12 volt battery is connected to resistor, 2.5 milliampere current flows through the circuit. If so, what is the resistance of the resistor? Here V equal to 12 volt, I equal to 2.5 milliampere. That is equal to 2.5 into 10 raised to minus 3 ampere, because milli represents 10 raised to minus 3. We have R equal to V by I. Therefore, R equal to 12 by 2.5 into 10 raised to minus 3. That is equal to 12 into 10 raised to 3 whole divided by 2.5. That is 12,000 divided by 2.5. Therefore, the answer is 4,800 ohm. 15th question. If 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm resistors are connected to a 9 volt battery in parallel, what will be the current through the 12 ohm resistor? Here V equal to 9 volt, R equal to 12 ohm, and we know that I equal to V by R, which is equal to 9 by 12, that is 3 by 4. So the answer is 0.75 ohm. 16th question. How many resistors of 176 ohm should be connected to parallel to get 5 ampere current from 220 volt supply. Here V equal to 220 volt. I equal to 5 ampere. We know that R equal to V by I. That is 220 divided by 5 equal to 44 ohm. Here the resistors are connected in parallel. So the effective resistance R equal to R by N. That is 44 equal to 176 divided by N. So the number of resistors N equal to 176 divided by 44, which is equal to 4. 17th question. Depict a figure showing the arrangement of 3 resistors in a circuit to get an effective resistance of 9 ohm and 4 ohm. This figure shows the circuits. The effective resistance of the first circuit is 9 ohm and the effective resistance of the second circuit is 4 ohm. Thank you.